Let's scale things up with resize. In resize, the user will provide us with a float by which they want to scale their in file and the name for an out file image. It's up to us to parse that float input, update the out file's header information, and then resize our bitmap accordingly, either making it smaller or larger than before. If we look at the distribution code, then we'll see that the implementation of copy.c satisfies a lot of similar functionalities to that of resize. Copy.c will parse an integer input, then open your in-file and out-file, updating the header information for your out-file and reading into the in-file scanline pixel by pixel, writing those pixels into the output file. So, perhaps our first step would be to copy copy.c into resize.c. But we need to parse floats, not integers. So check out the scanf function and the a2f function. Also make sure to check all corner cases, perhaps taking a peek into CS50's own getFloat function for more hints. Then we need to update the out file's header information. Now, bitmaps are simply an arrangement of bytes, just like any other file. It's just a matter of how we interpret this arrangement. So take a look into bmp.h for some documentation. Essentially, whenever we have a new bitmap, we'll need to update the header information. So what's changing when we're scaling up or scaling down? Well, the file size is going to change, as does the image size, the width, and the height of our bitmap. In the bitmap info header, we have the BI width, which includes the width of the image in pixels, not including padding, and the BI height, the height of the image in pixels. We also have the BI size image, which is the total size of the image in bytes, including the pixels and the padding. Moving to the bitmap file header, we have BF size, which contains the total size of the file in bytes. So that includes pixels, padding, and the headers. So of these values, what's changing when we scale our bitmap up or down by a factor of f? Well, BI width and BI height will definitely scale by f. So figure out how BI size image and BF size are also going to change. Now that we've updated the out file's header information, let's talk about resizing horizontally. So say the user gave us a float of 2. Well then, the algorithm would be pretty simple. For each pixel in the row, we would write that pixel f times into the out file row. All right, so now that we've figured out that pattern, let's talk about the two functions that we'll need to use. To read into the file, we'll use the fread function, and then to write the files, we'll use fwrite. So the next thing that we need to talk about is padding. In a bitmap, every pixel is 3 bytes long. Now, a requirement for the bitmap image is that the length of each scanline must be a multiple of 4 bytes. So, if the number of pixels is not a multiple of 4, then we'll need to add padding, where padding is just a single 0 character. In this example, I have 4 pixels in my row. Now, with 4 pixels, 3 bytes each, that equates to 12 bytes, so I won't need to add any padding. But instead, if I had 5 triples, then 5 times 3 is 15, not a multiple of 4, so I'd need to add 1 single padding character. Then if I had 6 RGB triples, I'd add 2 characters of padding. Finally, with 3 RGB triples, I'd add 3 units of padding. I've included the equation for padding here, and it can also be found in the problem specification. Notice how padding depends on the width of the bitmap and the size of an RGB triple. Now, the size of the RGB triple is going to be constant, so the only thing that might be changing is the width of the bitmap. So, if the out file and the in file have different widths, then they may have a different amount of padding. Remember our discussion about bitmap headers, where we calculated how the old header information might change for the out file. Well, because the padding is going to be different for the in file and the out file, then we may also need to keep track of that as well. Now, why do we keep track of both the old and the new padding? Well, we'll need the old padding because we'll want to skip over the padding in the in file using fseek. And then we need to know how much padding to add into the out file, and we'll use fputc to put those characters in. Now that we have a firm grasp on padding, we can resize our entire image. So once we figure out which row should be written, then let's seek to that, draw the pixels into the out file, and write the out file's padding. With that, we've resized our image. My name is Zamila, and this was Resize.